Hello, welcome back to our session 2 of TD revision. We were looking at our question paper here for building technician level 6. We did section A and now we are on our section B. Now section B starts with a question on conversion of areas where we want to convert a polygon into a square of the same area. Now before we proceed, I will kindly request you to subscribe to my YouTube channel. If you haven't, please subscribe and view all the videos. You can share the video links to your people. I will appreciate. Now this polygon here is of base PQ equal to 40 millimeters. So let's draw a 40 millimeters PQ. Now at Q we have 30 degrees. We draw a line 30 degrees. We transfer this same distance PQ to QR, which is 40 millimeters. Now PT is R equals to RS, which is 60 millimeters. So at P we have another angle which is 60 degrees. Along this line we are going to mark off 60 millimeters. We get our point T. Then we are remaining with point S. RS or ST is 80 millimeters and RS is 60. So this is 60 and then 80 TS. So we mark and get our last point. Yes. So we join all the lines. Now for us to get a square, first of all we transform this polygon into a triangle, and now we have to join line S to P and line from S to Q. Then we draw parallel lines to SP and SQ from T and R. So from R we draw a line parallel to SQ. So we use a straight edge and we draw this line which is parallel. Another line parallel to PS from T to meet the base. So we realign first, then we move along the straight edge and find for point T, and then we drop it down. I'm trying to bring this, okay, this way. So we can move and look for T and bring it down. We're going to name these points as U and V respectively. So you now draw a line from S to V. These ones are parallel. From S to V, then from S to U. So this triangle SUV is equal in area to the polygon. We can say area of this triangle VSU equals in area to our polygon, area of our polygon PQRST. So let's extend this line. We want now to convert our triangle into a rectangle. So we first of all drop a perpendicular from S to the base. So this is how we drop. So extend at 2 points and make arcs up and down respectively, which should cross to give us a perpendicular. So join this perpendicular to meet the base at a given point. And this point here we are calling it W. Now with SW we bisect length SW. So draw a line cutting through the points starting at V, we can draw a line to meet the bisector. So whatever we are getting is a rectangle. This rectangle is in equal area to the polygon and to the triangle. So I stand here and drop this line to the base by an arc. So we bisect line VA. This bisector gives us the midpoint of the line VA. So at a point where the bisector meets the base, we can call it B. And now we take a pair of compass standard B and take this radius BV and draw a semicircle. So then we are going to elongate alongside our rectangle on one side of the rectangle upwards. So we extend this line to meet the semicircle. Where the semicircle cuts through the line, we can call it C. So CU becomes one side of the expected square. So we just transfer all this because it is the same distance we transferred. Then we complete our square. So on completion, we get our square. You can as well name the vertices. Then now we can measure. This is area of a square equals to area of the polygon and equals to area of the rectangle and equals to area to the triangle. So we can measure. And this one we are getting it as 70 millimeters. So if you take 70 millimeters times 70 millimeters, get the area. That area will be equal to the area of the polygon. Thank you. Now let's proceed to the next question. Actually, this is the next part of the question. It should be 8, but question 8b. Now this one here is we are going to reduce a rectangle. The question reads, reduce a rectangle to a ratio to 3. So this rectangle measures 80 by 60. So you can complete the rectangle. Just take this side and cut along this. This is a complete rectangle. We are going to reduce this rectangle so that we get a smaller one. We are reducing by a ratio. We can name it as ABCD. So now we are using direct method. You can join the diagonal. Then along AB, you divide it into equal total ratio. Not really total ratio, but the 3 parts, which will be reduced to 2. So this is 3 parts. You can just move them or transfer them to the base AB using set squares. So the first one, second, and third. So move the first one. And these are 3 parts. And number 1, 2, 3. Now we reduce to 2. So we shall have a vertical line cutting through the diagonal from the second part. And this one is our reduced rectangle. So you can complete using your outline. We have just reduced a rectangle by a ratio 3:2, or 2:3, from 3 to 2. Next question is we are going to do orthographic projection in first angle projection. We have been given a solid figure here that have been shaped, as you can see. Now, how do we go about this? This is actually on we are still on this paper of Building Technician level 6, so don't get lost. So this is the question. We are going to convert it into orthographic projection. So first, we need to know how do we lay out views or elevation in first angle. So first, we need a front elevation, the plan, and end elevation. So from this direction on the left, you would see that the front elevation will be drawn on the right. And whatever we see in the front elevation are the following. We have this part, we extend it, and then we have the top part that has some circular hole driven all through. So we complete. And now we project downwards to get our plan. As you can see, our plan has some rectangle here and some circle there on the extreme side. So this is where it's starting from. It covers 40, it goes inwards, and then we have some circular part if you're observing from top. Then this one will extend, it goes inwards, follows suit, and comes back. This part here is curved, then we have its curvature. So we complete by also putting the circle, can be seen from top. Then we extend to draw our end elevation, of course. So we project from the plan back to upwards there to get our end elevation. All the details from the plan will be projected. It is important to sketch first before you draw it to scale. So what can we see in our end elevation? This is what we are seeing. We have the hidden hole here downwards, and this other line is also hidden. So the cutout of the base. So this is what we are going to draw to scale. This part, remember, it is 80, that is 80, yeah, because this is 60 plus this other part is 30. You don't need to put all the details of the dimensions, just have major ones that will guide you to go through. So first we are going to have a cross, and this cross here is where we are going to have all the views. So we can also have the guidelines here, 10 millimeters. So we use construction lines to draw. This one actually gives us the layout of the elevations so that they are uniformly spaced inside this cross section, inside this cross. So ensure you do it accurately so that vertical lines are strictly vertical and horizontal lines are strictly horizontal, as I'm doing. Now, first view is the front elevation. Now we pick the dimensions. The base is 80, so you can measure 80. And just make a mark here. You extend the line upwards, projection line upwards. Ensure it goes through downwards because it will also assist us when you are doing the plan. Now the height is 60 from our question. So this is 20. From this side, 20. The cut is 20. So draw these vertical lines, which are projection lines, as they are. Measures 30. Complete them. Then we have the circle here. Remember the outer semicircle is of radius 20. So get to know where 20 is. At that point, we are going to draw a center line. So the circle is of, the circular hole is of radius 10, 10. So that cylindrical hole is 10, 10. That's the radius. So you project them downwards, and these ones are going to be drawn using hidden line. The hidden lines to show the hidden detail, that is a semicircular or a cylindrical hole inside that particular solid. So we can have hidden lines. Okay, next you can complete by using outlines. The visible lines to be completed. These are object lines. Yes, I'm doing. This is the complete front elevation. Let's draw the plan. The plan is what you draw when you see this solid object from top. So as you can see, this side is 40. So you measure it. Let's project first of all downwards. Let's project these lines. The cylindrical hole should also be projected. Now this side, we can draw it. It's 40. Draw the line. So you draw this line. This other side, you draw it. Now the same circle, the circle again, you have to draw it. You establish the midpoint or the center, and then you draw a construction, a center line here. The radius of the circle is 10, so the outer curve is of radius 20, so you draw the same circle. And the circular hole is of radius 10, so you draw it. It fills the space. So you can complete the lines. This is what we draw when you see this solid object from top. This part here is going inwards by some distance. That's 15. It goes inwards. The cut is 15. So you complete this side and this side. This base here is a complete line. Then you connect these two. Now remember, this other corner here is curved, radius 20 millimeters. So you need to measure 20 millimeters. See where it is. It's a quadrant, so you measure 20, you cut on this side, stand here and cut, and also stand this other side and get the point, that is the center where you stand with your 20 millimeters to draw this curve. Just confirmation, and then you can join. So this is a complete plan. This is a complete plan. So now we project to this vertical line just to assist you get now the end elevation, because we shall build on this to get the end elevation. Ensure also the circle comes and meets that vertical. It's important. This vertical line. From here, you're going to stand at one of the corner of the front elevation and pick all the corners from the plan, and you make an arc towards the right hand side as I'm doing, just to get the end elevation. Now the end elevation is here with us. So we project these lines. All the lines will be projected upwards. This is the center, and then we have this is a projection line. It's also a projection line. So continue that way and ensure you complete this as it is from the sketch. Actually, we are just picking from what we have in the sketch as we transfer to the layout. So this side is visible, and also the base is visible, and the upper part visible up to there, the base up to the end. So we draw a straight line, an object line. This is a hidden line for the circles, the cylindrical hole. You have to indicate using a hidden line. Now this is also a hidden line. I'll complete this line and bring it back here and join it upwards. So you can dimension. Now in this case, I'm dimensioning our major dimensions. I'll just do an example here, and the rest can be done by my students, by you, my viewer. So this is just a guideline. This next question. So this next question, we are going to draw a plan of given front elevation of a truncated square-based pyramid. Square-based pyramid. So our front elevation is as it is. So we can draw the base here is 30. Now let's get the center line. This center line is going to guide us to get the vertex. Remember, in our question, we have not been given the height of the pyramid. It's just a truncated one on this side. Vertically is 40, and this other side where the truncation line meets. So we are going to have vertical lines at this end point, and then another vertical line here. Then we measure 20 millimeter on this side, another 20 millimeter. This other side is 40. So you can have a straight line passing through, the straight line passing through here. So we assume the height We assume the height, we take arbitral value of the height, vertical height, so we join the height to the 2 points, the base. Then now this point and this point becomes the points of our cutting plane. So we proceed, just take the base. Now question needs our plan, so we can project from the front. This is the front. We can project from the front to get the plan. This side can be projected downwards. This other side we projected downwards. Now our base is 40 by 40. So we transfer 40 here. This side, also transfer this other one, this other side, and we join. We can label, have diagonals AC and DB. We are completing our plan. So draw vertical lines from our front elevation to meet the plan. Of course, it's going to cut through the diagonals. This one will show us how the cut face appears on the plan. So you can join with straight lines. You join this at the base, at the sides of the base, and also the diagonals that meets the cut face. We can complete it this way. We do the hatchering of the cut face. This face is a face that has been cut by a triangulation line. So that is it. Next, we are supposed to draw a true shape. True shape is what we see as the cut face from the perpendicular side. We observe the cut face perpendicularly. So this is how we draw perpendicular lines to the cut face. So we transfer from the base reference point to every point on the cut face. Back here, we stand there and cut. Come and pick this other point here. Go with it up and cut, and come with this. Move with it up and cut. So we join, and this one becomes the true shape. That's how the cut face appears truly. True dimensions. Next is to draw the development. Now the development, you stand at the center and make an arc, because we are going to use what you call a true length, and have the center line where the two meets. You project upwards to meet the reference line, and now join to the vertex. So we can call this as Vx, and Vx becomes a true length that we are going to use to draw a development. So have a beginning point, take the true length as it is, Vx, stand with it at this point and just draw a curve. You can join a line from that point to the curve at any point, and you can label as A. Maybe we are cutting it, or we are developing it from A, so you can name this as A. So take the base side and transfer it to the curve B, C, D back to A. So join straight lines from every point, vertex to the vertex. We are doing development of the lateral face. Next, you pick with your pair of compass from the vertex to those points where the cutting plane meets the slant lines, and you transfer. This is on A and B. This other one is on C and D. So you pick this and transfer to C and D. Then join. So join all these points. The straight lines enjoying the way I'm doing. It's just a development. It's a complete plan. This is a true shape. This other one is development of the lateral face. Thank you very much. Please subscribe. Don't forget subscribing. Thank you.